Hello everyone, welcome to my YouTube channel. We are going to talk about the potential energy which is possessed by a dipole when it is placed in a uniform electric field. And in order to calculate the value of potential energy, first of all we need to consider a pair of equal and opposite charges separated by a very small distance taken to be 2a, and this distance is called a length of the dipole. Also, we need to consider that this dipole is placed in a uniform electric field, and uniform electric field could be represented by the parallel lines which should be equidistant apart. Hence, we are having a electric field E in which our dipole is placed such that this dipole is making an angle theta with the direction of uniform electric field. In the previous article, we discussed that torque experienced by a dipole when it is placed in a uniform electric field is given as tau is equals to Pe sine theta. So we will mark this equation as equation number 1 because we are going to use this equation. Now our area of interest lies in finding the value of potential energy which is possessed by a dipole. So in order to find the energy, whatever kind of energy it is, whether it is a potential energy, it is a kinetic energy, or whatever other form of energy is, we always need to find the work done because we always define energy in terms of work done. As the definition of energy says, it is defined as the capacity to do work. Therefore, whatever kind of energy we want to calculate, we just need to find the total amount of work done. Here, torque is doing a work in rotating the dipole from some initial angle to the final angle. Therefore, we already learnt in class 11th that work done by the rotational force is given by dw is equal to tau d theta. This is the small amount of work done in rotating the dipole with a very small angle, that is d theta, but I am interested in finding the total work done because total work done is going to be stored in the form of potential energy. In order to do that, I just need to put the value of torque in this equation. Therefore, small amount of work done dw is equals to Pe sine theta d theta. As I said that we need to find the total work done, therefore we will integrate this equation, that is total work done W is equals to integral of dW is equal to integral Pe sine theta d theta. As the angle is going to change from initial angle to final angle, therefore let us say the initial angle which the dipole was making with the direction of uniform electric field was theta, and the final angle after experiencing a torque it makes with the uniform electric field is taken to be theta 2. Therefore, we have total work done W is equal to Pe integral theta 1 to theta 2 sine theta d theta. Now question arises why I have taken P and E out of the integral. If we recall the definition of P is dipole moment which is equal to length of the dipole multiplied by the magnitude of either charge. Therefore, P is constant and hence it could be taken out of the integral. Also, it is already mentioned that electric field is uniform, therefore its value is also constant and hence it could also be taken out of the integral. Hence we could write W is equals to Pe integral theta 1 to theta 2 sine theta d theta. Now we already know integral sine theta is minus cos theta. This implies W is equal to Pe minus cos theta and limits changing from theta 1 to theta 2. I have not substitute any limit yet, so we need to solve it out. We get W is equal to minus Pe cos theta such that theta 1 to theta 2 is our limit, and now substituting the upper limit and lower limit, that is W is equals to minus Pe cos theta will be, this theta will be replaced by upper limit, we will write cos theta 2. Now we will put minus sign and this theta is now going to be replaced by theta 1. So minus cos theta 1. Therefore we have W is equal to minus Pe cos theta 2 minus cos theta 1. Taking this negative sign inside, we will get it is equals to PE minus cos theta 2 plus cos theta 1, and rearranging the terms we get W is equals to PE cos theta 1 minus cos theta 2. So this is the expression of the work done by the torque when dipole is rotated in a uniform electric field from angle theta 1 to theta 2. But now we need to consider a case, that is, if initial angle theta 1 is supposed to be 90 degree and final angle theta 2 is supposed to be of theta, then we will get W is equal to PE cos 90 minus cos theta. Then we have W is equal to PE, and we know cos 90 is 0 minus cos theta. So it is equals to minus PE cos theta, and this work done is equals to minus PE cos theta is stored in terms of potential energy possessed by the dipole, and hence this expression gives us the amount of potential energy which is possessed by a dipole. Now we can also write it in the vector form as u is equals to minus p vector dot e vector, because whenever we remove cos theta we always put a dot product over here, as we have learnt this concept in class 12th kinematics unit. Now I also want to discuss more cases, that is, if dipole becomes parallel to the direction of the electric field. How the dipole is going to become parallel with the direction of electric field? When this dipole will get rotated such that plus q charge lies over here and minus q charge is lying over here, that is theta becomes 0 degree. So if this will happen, that theta becomes 0 degree, then u is equals to W is equals to minus PE cos 0, it is equals to minus PE, because cos 0 is 1, therefore we can say potential energy in this case U is equals to minus PE, and this potential energy is minimum, hence we can say the dipole is in stable equilibrium. And second case, if theta is equals to 180 degree, U will be equal to W is equals to minus PE cos 180, and we know cos 180 is minus 1, therefore minus PE and cos 180 is minus 1, and minus 1 into minus PE, answer is PE. So potential energy will become U is equals to PE, that is the potential energy will become maximum, and we can say that the dipole is in unstable equilibrium. So this is all about the potential energy possessed by a dipole when it is placed in a uniform electric field. I hope you have understood the concept, and if you have understood the concept, please do not forget to press like, subscribe and share button, and also press the bell icon in order to get the latest updation on my new videos.